The first one says, find the derivative of f of x equal to s squared from first principle. Okay, so if f of x is equal to s squared, now our goal when taking derivative from first principle is to try to express the gradient of this function in this format: f of x plus delta x minus f of x over delta x, and then take the limit of this. The limit of this will give us the derivative of this function from first principle. So if f of x is x squared, what will be f of x plus delta x? F of x plus delta x squared. And x plus delta x squared means x plus delta x times x plus delta x. So we are going to expand this. So this will be x plus delta x. X times x is x squared. X times delta x is x delta x. Now, one common mistake that students make is to multiply this x with this x here. This x is attached to delta x, so you can't multiply with this x here. This x here, you cannot multiply with this and say it's delta x. Well, no, that is wrong. This x and delta x are together. They are not separate entities, so you cannot multiply this by this and call it x squared. That would be wrong. So instead of delta x squared, it is x delta x. That is the point I'm making there. Now delta x times x, again, is x delta x. Then delta x times delta x is delta x squared. When you can say I put the delta x squared in brackets, that is square. This delta x is a single variable in this case. And that is the reason why you cannot multiply this x by this x. Okay? So in this case, this will be x squared plus x delta x plus x delta x is 2x delta x. Then plus delta x squared. So it's f of x plus delta x that give us this. F of x, let me write it. F of x plus delta x give us that. Now, recall I said earlier that whenever you are taking derivative from first principle, your goal is to try and express the derivative of that function in this f of x plus delta x minus f of x divided by delta x. So we are trying to arrive at this and then take the limit of reciprocal. So in this case, now I have f of x plus delta x equal to x squared plus 2x delta x. F of x plus delta x minus f of x. That would be x squared plus 2x delta x plus delta x squared minus, what is f of x? F of x is x squared. So as I subtract f of x on the left-hand side, I have to subtract it on the right-hand side too, because I'm trying to arrive at that first principle derivative of first principle. So minus x squared here, so that this will go. That means f of x plus delta x minus f of x is equal to 2x delta x plus delta x squared. And the last stage, again, what we are trying to arrive at is this. Let me write it here so I don't have to clean it again. F of x plus delta x minus f of x. Now we have f of x plus delta x minus f of x here, which is equal to 2x delta x plus delta x squared. So the next thing now is to divide both sides by delta x here, so that we can arrive at something like this. So f of x plus delta x minus f of x divided by delta x is equal to 2x delta x plus delta x squared divided by delta x. Since delta x is common to both of them, let's factorize it out. So delta x into 2x plus, now I have delta x squared here, but I factorize it now, so I'll be left with only one delta x here, then divided by delta x. So this delta x can cancel this delta x. So I have f of x plus delta x minus f of x divided by delta x is equal to, and finally, the limit of f of x plus delta x minus f of x over delta x as delta x approaches 0 is equal to, if I take the limit of this, the limit of sum is equal to sum of the limits. That is one of the properties of limit we learned in our previous lesson. So limit of 2x plus delta x, and then that will be limit of this sum. Limit of 2x is as delta x approaches 0, so that this becomes 2x. Therefore, the derivative of f of x equal to x squared is 2x.